Now, the directions said we have to isolate a radical on one side. Well, I've got two radicals on this side, so they're not isolated. So what I'm going to do first is move the second radical. I'll have the square root of 2x plus 3 equals the square root of x plus 1 plus 1. Now I have to square both sides. And I'm squaring the whole side. Not the parts of the side, but the whole side. So the square root of 2x plus 3 squared is 2x plus 3. And I'm good. But now I'm squaring the whole side. So square the first term, I'll get x plus 1. This is like squaring a binomial. So multiply the first and second term together and double it. So I'll have plus 2 square roots of x plus 1, and then square the last term plus 1. Now, because I still have a radical in this, which I expected since I started with 2, I'm going to have to square both sides again. So I want to isolate this radical by moving the x plus 1 and the plus 1. So that'll give me x plus 1, subtracting an x and subtracting 2 ones, equals 2 times the square root of x plus 1. Now it's okay to leave this 2 factor in front as long as we make sure we square it also when I'm squaring the whole side. So x plus 1 squared is x squared plus 2x plus 1, always remember middle terms, equals, this will be 4 times x plus 1. So x squared plus 2x plus 1 equals 4x plus 4. Getting that on one side of x squared minus 2x minus 3 equals 0. Oh, that factors into x minus 3 times x plus 1. So x equals 3 and x equals negative 1. These are my two proposed solutions, but I must check them in the original equation. So checking the 3, 2 times 3 is 6 plus 3, I want that square root, minus the square root of 3 plus 1 equals 1. Well, this would be 9 minus 2, or 3, 9, square root is 3, and 4, square root is 2. So 3 minus 2 equals 1. This one checks. Let's check the negative 1. 2 times negative 1, so negative 2 plus 3 is 1, minus negative 1 plus 1 is 0, equals 1. Well, the square root is 1, square root is 0, equals 1. So that both checks. And both of these solutions work. Again, we need to square in each side to solve the equation, and we do have this radical isolated. So we can go ahead and square both sides right now. Remembering you're squaring the whole side, not just each term. So x plus 2 equals, square the first term. Multiply the two terms together and double it. So we'll get negative 2 square root of 3x plus 7. And when I square the last term, I get 3x plus 7. Well, we're going to want to isolate this, so let's move these. Negative 2x, we've got 8, so minus 6 equals the negative of the square root of negative 2 times this 3x plus 7. Well, these are all negatives. I'm going to multiply everything by negative 1. I'm going to get 2x plus 6 equals 2 square roots of 3x plus 7. Now I won't have to worry about all those negative signs and keeping track of them. square each side. So 2x plus 6 squared. Square the first term is 4x squared. Multiplied together is 12. Double it. 24x, and square the last term, plus 36 equals 4 times the 2 squared, 3x plus 7. So 4x squared plus 24x plus 36 equals 12x plus 28. It's a square root, so I need to get it all on one side equal to 0. That will give me 4x squared plus 12x plus 8 will equal 0. Well, when I do that, let's just divide everything by 4. So I'll get x squared plus 3x plus 2 equals 0. Oh. That factors into x plus 2 times x plus 1 equals 0. So x equals negative 2 and x equals negative 1. Checking these solutions then. These are my two proposed solutions. The negative 2, so I'll have the square root of negative 2 plus 2 equals 1 times the square root of negative 2, negative 1 minus the square root, negative 2, so it'll be negative 6 plus 7. 0 equals 1 minus 1. That checks. And the second term, square root would be negative 1 plus 2 equals 1 minus the square root will be negative 3 plus 7. So this will be 1, the square root of 1 equals 1 minus, this will be 4, 2. 1 does not equal 1 minus 2. So this root does not work, and my only solution is x equals negative 2.